Good evening, friends. Uh, Today we are studying about the circle. आपण वर्तुळ सर्कल या चॅप्टरमध्ये we will studying the different points. त्याच्यामध्ये फर्स्ट आहे सर्कल्स passing through 1, 2 and 3 points. Circles touching each other. Inscribed angle and intercepted arc. Secant tangent angle theorem. Secant and tangent, arc of a circle, cyclic quadrilateral, theorem of intersecting chords. तर अशा पद्धतीनं या सर्कल वर्तुळ या चॅप्टरमध्ये आपल्याला वेगवेगळे पॉईंट्स शिकायला मिळणार आहेत. इयत्ता 9वी मध्ये आपण सर्कलबद्दल स्टडी केलेला आहे. त्याच्या पुढील भाग जो आहे तो क्लास 10th मध्ये आपल्याला शिकायला मिळतोय. We are familiar with the concepts of circles like center, radius, diameter, chord, interior and exterior of a circle. आपल्याला फिगरमध्ये इथं दाखवलेले पहा दोन सर्कल्स आपल्याला दाखवलेले. these are the congruent circles. आपल्याला असं दिसतंय की these two circles are having the same radius. आणि जर दोन सर्कलची रेडियस ही सेम असेल तर these are called as the congruent circles. इथे एक सेकंड डायग्राम जे आहे त्या डायग्राममध्ये आपल्याला असं दिसतंय की these are concentric circles. That means these both the circles are having a one center. So that's why these are called as concentric circles. And the third diagram is that we can see this is the intersecting circles. The circles with the different centers are intersecting each other in 2 points, and these are the intersecting circles. This is the part of some recall about the circles. Then we will see the first activity which is belonging to the circle. Activity first. In this we can see in the adjoining figure the segment DE is a chord of a circle with center C. On page number 47, figure 3.1, we can see the segment DE is a chord and CF is the segment which is perpendicular on the chord DE. If the diameter of circle is 20 centimeter and DE is 16 centimeter, then find CF. That means the length of chord is given. The length of segment CF, which is perpendicular on the chord DE, is given, and we have to find the radius is given, and we have to find the segment CF which is perpendicular on the chord DE. For that purpose, we know that we have to find the DF. The chord DE is given. We know the property that the perpendicular drawn on a chord from the center of circle bisects the chord. That means that DE is the chord which is bisected by the perpendicular CF. Therefore DF is equal to FE or EF. That means if the segment DE which is given, segment DE is given as 16 centimeter, then we get DF is equal to 8 centimeter. The diameter of circle is given as a 20 centimeter, therefore the radius is of 10 centimeter because the radius is half of the diameter. CD we can draw the segments CD and CE. These CD and CE are the radii. That's why CD is equal to CE is equal to 10 centimeter. We have DF is equal to 8 centimeter. CD is equal to 10 centimeter. By using Pythagoras theorem, we can find the CF. This is the simple way by which we can find any of the segment in this diagram. Then we will march to the next point, activity second. In the figure, segment QR is a chord of the circle with center O and P is the midpoint of the chord QR. Okay, we have given P is the midpoint of chord QR. That means we know the property that the segment drawn from the center of circle on a chord bisects the chord. That means P will be the midpoint of the chord QR and OP is the perpendicular drawn on a chord. Okay, then in the adjoining figure, segment QR is a chord of circle with center O and P is the midpoint of chord QR. If QR is equal to 24, OP is equal to 10, QR is given as 24, OP is 10, then we can find the radius of the circle as well as we can find the diameter of the circle by using Pythagoras theorem, because the perpendicular drawn, that means the segment OP is perpendicular on the chord QR, and that's why angle OPQ is equal to 90 degree, angle OPR is equal to 90 degree. That's why this OQ or OR are the radius and are the hypotenuse. That's why we can find the hypotenuse by using Pythagoras theorem. This is the activity second, which is a part of recall about the circle. Then we will turn towards the activity 3. In the adjoining figure, M is the center of circle which is given. We can observe the figure 3.3 to know more. In this, M is the center of circle and segment AB is a diameter. Segment MS perpendicular chord AD, segment MT perpendicular chord AC, then angle DAB congruent angle CAB. Prove that chord AD congruent chord AC. That means we have to show these chords are the congruent chords. That means the length of both the chords is same. Chord AC congruent chord AD, that we have to show. To show these chords as the congruent chords, we must know something that, and we have seen the activity first and second. The perpendicular drawn from the center of circle to the chord bisects the chord. That means in case of chord AD, we can show AS is equal to DS. In case of segment AC, we can show AT is equal to CT. And MS perpendicular AD which is given, MT perpendicular to AC which is given. In this figure, we can see that the two triangles are formed, triangle ASM and triangle ATM. These two triangles are formed in this side AM, congruent side AM. That means every segment is congruent with itself. That's why AM is one of the congruent side. Then we have given that angle SAM is congruent with angle TAM, which is also given, is the second congruency, that is congruency of angles. And third one is SA or AS congruent AT. The perpendicular drawn from the center of circle bisects the chords. In this, these both, that means triangle SAM or ASM and triangle ATM, these both the triangles are right angle triangles. Hypotenuse side test is one of the method of congruency of right angle triangles. In this, AM is the radius and one of the side of these two triangles. Then AS and AT are the two sides which are congruent sides, because in both the right angle triangles, if the hypotenuse is same, then obviously the pair of these two sides is same. That's why these two right angle triangles are same. If AS and AT is same, then AS is congruent with AS is equal to DS and AT is equal to CT. That's why we can write this AD and AC are the chords which are of the same length. Okay, that means by hypotenuse side test we can show these two triangles as congruent triangles and these two chords as congruent chords. In this way, we have learnt about the three activities which are related to the circles. Then we are going towards the circles passing through 1, 2 and 3 points. In this figure 3.4, we have given a diagram. We will simply read about this. In the adjoining figure, point A lies in a plane. All the three circles with centers P, Q, R pass through point A. How many more such circles may pass through point A? Then we know that from a single point, infinite number of circles can pass. Okay, we know that. And in the adjoining figure, that is figure 3.5, we have given 3 points, point A, point B and point C. And the question is again same, that means how many circles pass through points A and B. That means from the 2 points, by using these 2 points, how many circles we can draw, and by passing through these 3 points, how many circles we can draw. These are the questions which are given in this figure. Passing through these 2 points, we can draw only one circle. We know that by max one number of circle we can draw, and passing through these 3 points, if these if possible, we can draw the circle passing through these 3 points. Okay, then in the next lecture, in the next session, we will continue from this page number 49. Till then, we will stop here. Thank you.